So we started out today by looking at lemma 3.2.1, which was the proof that if I have parallel cutoff of two segments in a triangle, that implies a proportionality between the lengths of the segments which are cut off. And we decided to prove that in a fashion similar to the proof of the midline theorem, where we extended one of the segments in such a way that we constructed a parallelogram. It was a parallelogram because by construction it had two pairs of opposite parallel sides. And that parallelism gave us so many congruent angles in our figure that we were able to demonstrate that the smaller triangle that we were interested in, ADE, that smaller triangle was actually similar to SEC, another triangle inside of this. But in order to get that similarity, we had to invoke the AAA criterion. Remember, the AAA criterion says that having congruent angles is sufficient to also have proportional sides. That was something we didn't know in the beginning, and we chose to use it in the service of this proof, thinking that we could get away with it. It turned out that, in fact, we can't. But if we do get proportionality of the sides, then because we ended up constructing a parallelogram in that original figure, and because parallelograms have congruent opposite sides by 2.3.1, we ended up getting an equality of two proportions, one denominator of which we can swap out with dB, and proving the statement that we were trying to prove. AD over dB is equal to AE over CE. But of course this was all provisional because we needed to know that we can use the AAA criterion to guarantee similar triangles. And if the AAA criterion's proof depended upon this very result, then we end up with a problem. And so when we went forward to look at the proof of the AAA criterion in 3.3.1, we found out that the method of proof chosen by the author was to take the smaller of the two triangles and situate it inside the bigger of the two triangles. So that's the artistry of this particular proof. And the AAA hypothesis then guaranteed for us some congruent angles. We had a congruent angle at A, and that needed to be congruent in order to place this triangle inside of the bigger triangle at all. And then the remaining pairs of congruent angles, here and there, we needed those to be congruent so that we can invoke theorem 1.3.1, which guaranteed for us that then BC is parallel to EF. And because BC is parallel to EF, we have a theorem, 3.2.4, which will guarantee for us the similarity of the two triangles that we were trying to show were similar. And of course the problem with that whole thing is that the proof of theorem 3.2.4 relied upon the result of lemma 3.2.1, but we used 3.3.1 itself to prove 3.2.1. And that's a problem because we can't use a theorem to prove itself. That's circular reasoning. So what we're going to do, one last time, is we're going to take this proof as the proof that we'll use for the AAA criterion, and we will revisit how 3.2.1 is proven later on in the course using an area argument that the author uses in kind of a somewhat cheap way because we haven't talked about area yet at that point.